Let's talk a little bit more about this idea of nav meshes or navigation meshes. So nav meshes are used to represent our 3D worlds using 2D polygons. And these nav meshes or navigation meshes represent areas that are walkable by our AI. I'm going to just create an example level here real quick that might look something like this. Here's a very simple level. It's 3 rooms and connected by these small spaces between them. A navigation mesh generation on a level that looks like this may generate a series of different meshes. It would generate one mesh that represents this room, probably something similar to this. It would generate another mesh, which represents this hallway, this space here. It would generate another mesh, which represents this room, probably something similar to this. Another mesh down here, which represents this room. And it may actually represent or have some other small connecting meshes between. Navigation meshes and the generation process around them typically don't create nice, clean meshes like this. But for our intents and purposes right now, this will do good enough. Now, navigation meshes allow us a couple different things. They provide us the additional knowledge of all of the walkable space. By walkable, I mean areas where our AI can actually walk. If we have an AI that's standing at this position here, this AI can walk anywhere where a nav mesh is in our world. It can move anywhere around this space or onto this green space, the purple area, or even down here onto this blue area. Anywhere that's been colored in by these navigation meshes, the AI can stand. And this is why typically these things are connected to each other to represent that the AI could move all the way smoothly between. So a second thing about navigation meshes like this is they represent how areas connect to each other. So they represent connected spaces. Just by looking at this, I can tell that this navigation mesh here is connected to this green one just by nature of it being overlapping or touching one another. And then this navigation mesh is connected to the next one here in this room because they're overlapping, and same thing with these two here, right? So it's pretty easy for me to see that my AI could move down to this room by moving through these hallways and staying on these navigation meshes, right? Navigation meshes also represent this connectivity typically through an underlying graph data structure. So in this example here, we can see that these two meshes are connected to one another due to this overlap. These two meshes are connected to one another due to this overlap. And these two meshes are connected to one another due to this overlap. This is very similar to a graph that looks like this. Here's my orange room, which is connected to my green room, which is connected to my purple room, which is connected to my blue room, right? Typically, when AI are navigating along these meshes, it's giving us two different sets of data, essentially, that we can operate on. One is which meshes, sort of like a higher level, is which meshes do I need to traverse through to get to my ultimate goal. The second one is how do I navigate a little bit more locally. So to give a better example, if my AI is up here on this orange mesh and it wants to navigate here to the blue mesh, the first thing my AI could do is, instead of looking at these complex shapes, it could look at this data structure. Well, I'm currently here on my orange mesh, and I want to move to my blue mesh, which is this one. Now I can do a very simple search function on this graph using breadth first search or Dijkstra's algorithm or A* commonly. That will tell me the path I need to take goes from the orange to the green to the purple to the blue. It goes along this path here. Now I know, my AI knows, that to traverse from this area here where the orange is to get to this blue area, I need to go first to this mesh, then to this mesh, then to this mesh, and then finally to this final mesh. Now I can do some additional path smoothing to figure out exactly how I want to navigate to that area. One of the nice things that this affords us is because this provides the knowledge of all of the walkable space, now that I know that my path goes from 1 to 3 to 4, I could say, all right, this is a human and it's going to walk something along these lines, something like this. I can generate a nice smooth path, and it's always on these walkable spaces, moving from one mesh to another. Right? This is a huge benefit over our node-based pathfinding system previously, or the grid-based pathfinding system previously, where our AI had to move to specific positions. Another thing I could do, actually, if I really wanted to, is I could say, you know what? This AI needs to make it to this position, but it's trying to avoid other players, and it's trying to do so in a dynamic way. It's avoiding things that are on the ground, or it's playing a game of tag, and it's moving left and right and sort of juking around and stuff. I could generate a path that goes from this position to this final position. As long as it remains on these navigation meshes, it will be valid. So I could generate a path that looks like this. And that's also a valid path. Notice how it just goes wherever it wants on the orange mesh, and then goes to the green, and then to the purple, and then eventually makes its way around and gets to the goal. That's still following and using all the knowledge of this navigation mesh to generate a nice valid path for our AI. So navigation meshes like this, because they're providing the knowledge of all walkable spaces and represent the connectivity between these spaces, allow us as AI developers the flexibility to generate some interesting paths and interesting decisions in how our AI moves through the world.